Hello, dear viewers. In this section, we will explore the possibility of a theoretical framework that combines subjective and objective understandings of time through a fractal model. This model attempts to combine the emergence of time from timelessness via fractal self-similarity with the subjective experience of time. The approach not only explores the cosmological foundations of time, but also integrates phenomenological aspects such as repetition, attention, and intention. The idea that time emerges from a timeless substructure through fractal-like processes is both provocative and conceptually rich. The fractal paradigm described in the previous sections provides the basis for understanding how time emerges through self-similar patterns that recur across scales. In this view, repetition corresponds to the fractal measure n and represents the number of self-similar structures per scale level, while scaling relations encompass transformations across temporal layers. Fractals are a powerful mathematical metaphor here. They are inherently timeless in the sense that their self-similar structures are invariant across scales. Subjective experiences, such as attention and intention, resemble fractal scales. This suggests that these variables are not merely psychological constructs, but are grounded in a deeper cosmological substructure. Is time itself a constructed phenomenon? And if so, does its construction depend on the observer's interaction with scale and repetition? The proposed triad of repetition, attention, and intention links fractal principles to subjective temporal experience. Repetition contributes to the construction of time independently of conscious experience by structuring tasks through patterns. This is consistent with the idea that repeated repetitions consolidate memories and minimize the subjective sense of effort or time consumption. The connection with the fractal measure n, the number of self-similar structures, suggests that repetition solidifies temporal frameworks at both the micro, daily tasks, and macro, cosmological processes, levels. Attention acts as a synchronization mechanism for timescales or frequencies, similar to how fractals distribute complexity through scaling factors. The concentration of moments on memory highlights how attention operationalizes the fractal properties of self-similarity and scaling in subjective cognition. As described, synchronization resonates with the principles of resonance in dynamical systems. For example, just as attention modulates temporal perception, physical oscillators synchronize at shared frequencies, revealing deeper similarities between cognition and physics. Intention, on the other hand, has been likened to Penrose's insight, suggesting an active engagement with the infinite potential of timelessness. This transcendent aspect connects intention to higher-level processes that draw patterns unconstrained by scale. In practical terms, it may reflect how this directed focus shapes subjective experiences of time. Objective time is external and measurable, governed by standard clocks. Subjective time, however, is phenomenological and shaped by variables such as repetition, attention, and intention. The model successfully demonstrates how this disconnect arises. Repetition reduces the subjective sense of duration due to familiarity and reduces attentional demands. Attention stretches time when tasks are novel or challenging, reflecting the scaling effect of high cognitive load. Intention creates a connection to potential timelessness, enabling moments of deep focus or insight that stretch or suspend time. This fractal interpretation implies that subjective time is not merely disorganized or out of sync with clock time, but is actively shaped by fractal-like dynamics within cognitive structure. Repetitive repetition stabilizes memories and protects them from decay. It influences the subjective perception of time by regulating attention. For new experiences, attention is intensely engaged in assimilating external data, leading to a prolonged sense of duration. Subsequent repetitions focus the experience on meaningful aspects, reducing attentional demands and therefore perceived duration. This relationship reflects how fractal systems achieve efficiency by reducing dimensionality through scaling. Similar to redundancy in data compression algorithms, this fractal coding prevents loss of temporal resolution over time. This correlates well with Hebbian learning in neural networks, where repetition strengthens synaptic connections and leads to more efficient cognitive processing. Attention emerges as the second critical variable that is intricately linked to the scaling factor S in fractals. Attention is defined as being inversely proportional to S. The more attention is focused on a moment, the less it is compressed, leading to higher memory resolution and richer subjective experience. The fractal dimension is expressed as log n divided by log s, where n represents the number of repetitions and s the scaling factor. When reframed for time, this corresponds to temporal density, the richness of a moment determined by the interaction of repetition and attention. Higher attention and repetition increase density, producing a vivid and prolonged sense of time. Attention minimizes information entropy by reducing compression or increasing detail. Conversely, reduced attention allows for greater compression, increasing information loss. The relationship of S to entropy provides an intriguing bridge between physics and cognition, as both describe the tendency of systems toward simplicity or complexity. The deepening of time assumes cosmologically that fractal structures underlie the large-scale emergence of time and reflect subjective dynamics. This convergence of cosmological and psychological insights suggests a deep unity. Both scales can share fundamental principles, but this raises ontological questions. Is the fractal model merely descriptive, or does it reveal a fundamental feature of reality? Can fractal dimensions be quantitatively linked to subjective temporal experiences? How do fractal dynamics emerge in the physical and neural systems? Is the fractal nature of time emergent or fundamental? This theory, which combines timelessness with temporal experience, requires us to rethink time not as a fixed dimension, but as a dynamic interplay of scales, patterns, and consciousness. The compression of memory is inversely proportional to its resolution, paralleling how image compression reduces detail. High-attention moments create high-resolution memories, while less-attended moments are compressed and become harder to remember. Neuroscientific studies on memory encoding and retrieval could benefit from this framework. For example, fractal-based models of hippocampal activity could explain how memories at different resolutions are organized and accessed. In this section, we will bring together phenomenological, cognitive, and cosmological perspectives to show how subjective time accelerates with age and how moments are nested within each other in a fractal, self-similar relationship. Let us begin our discussion with a reflection on the paradoxical experience of time accelerating with age. Two factors are presented to explain this phenomenon. A year constitutes an increasingly smaller fraction of a person's life. A year is 20% of a person's life for a 5-year-old, whereas for a centenarian, it is only 1%. This proportionality leads to the subjective sense that time passes more quickly as a person ages. The concept of time density refers to the subjective experience of cramming more into less time as life progresses. Skills acquired through repetition require less attention and free cognitive resources. This acceleration of subjective time is associated with an increasing temporal density corresponding to the pace of life. Temporal density resonates with cognitive load and attention patterns. Neuroscientifically, as procedural memory tasks become more automated, attentional demands decrease, effectively reducing the subjective duration of repeated activities. The fractal analogy offers a structural explanation. Repeated actions condense temporal experiences into patterns, reflecting the compression of information in fractals. Each year, or temporal unit, is conceptualized as a harmonic, with successive harmonics representing finer divisions of time. The first harmonic represents the entire first year, while the second harmonic divides this pattern into two nested sub-patterns. Subsequent harmonics create a fractal-like nesting of time by embedding increasingly compressed versions of the first pattern. The fractal property of self-similarity is evident in this model. Just as fractals replicate their structures across scales, each successive temporal segment embeds and references previous patterns. Time is not simply a linear sequence, but a repetitive structure. Past moments are condensed into present moments, affecting and shaping the present while maintaining an intertwined, self-referential relationship. Procedural memory consolidation shifts cognitive processing from high-demand cortical regions to low-demand subcortical structures, effectively freeing up the brain's attentional resources. Temporal compression due to reduced attention reflects the scaling factor in fractals. Just as fractals achieve efficiency by reducing dimensionality, the brain compresses repeated temporal patterns into lower dimensional representations. The mutual embedding of past and present aligns with process philosophy, which emphasizes the dynamic, interdependent nature of temporal reality. It also evokes quantum mechanics, where entanglement connects the past and present in non-local ways. The timeless nature of the fractal prime, the smallest indivisible temporal unit, underscores the ubiquity of patterns across scales. This perspective challenges linear notions of time, suggesting instead that time emerges as a fractal elaboration of an underlying timeless substrate. A fractal perspective on temporal evolution. We will now consider the concept of temporal depth, explaining how time moves from a timeless state to a layered structure embedded in consciousness, memory, and the cosmos. Temporal depth is defined as something that emerges through a fractal-like process of compression and repetition, where the memory of each moment nests within the next. This is consistent with Bohm's idea of nested, folded memory, and suggests that time carries traces of the past in each present moment, like Russian dolls or Chinese boxes. This concept of temporal depth is compelling because it parallels physical processes such as wave interference and the holographic principle in theoretical physics, where past states influence and inform present configurations. Repeated events, such as seasonal changes, create cycles, which eventually become linear sequences when attention is drawn to the differences between cycles. For example, each autumn can be seen as part of an endless archetypal autumn until the distinctions between particular years become apparent, transforming the cycles into sequential entities. Separating one cycle from another leads to a linear perception of time. This transition from cyclical to linear time reflects the developmental patterns of human consciousness, in which the understanding of time evolves from implicit, cyclical patterns to explicit, linear frameworks. In the timeless state, early consciousness exists in a state similar to dreamlike timelessness. In cyclical time, consciousness begins to perceive repetitive patterns. In linear time, awareness of sequential events emerges. Integral time eventually develops into a holistic integration of timelessness, cyclicity, and linearity. The fractal model culminates in the concept of integral time, where timelessness, cyclicity, and linearity coexist as a unified temporal framework. Integral time encompasses the qualitative and quantitative aspects of time by combining the subjective and objective dimensions. It provides a framework for understanding temporality not as a fixed, linear progression, but as a dynamic interplay of interlocking structures. Time evolves from a timeless state to a layered structure embedded in consciousness, memory, and the cosmos. This process can be explained in physical and philosophical terms and reconstructed with a fractal model. The early universe is associated with timelessness during a period when radiation energy density was dominant. Photon timelessness is associated with a being moving at the speed of light, not experiencing time. However, when photons interact with matter, they are pulled from timelessness into time. This process means that timelessness is divided into time as energy is transformed into matter. Just as an infinite moment breaks apart to create the flow of time, each photon interaction represents the rebirth of time. This transition period marks the point in cosmology where matter becomes dominant and temporality becomes dominant. In the early universe after the Big Bang, radiation density decreased over time and remained below matter density. This transformation gave rise to the cosmic microwave background radiation and shaped the universe's perception of time. The fact that every point in the universe was once the center and that looking into space is equivalent to looking back in time defines the universe as an omnicentric structure. The fractal nature of time emerges from the continuous division of an infinite moment. Each wave function collapse, each particle-antiparticle pair creation is a moment when time is reborn from timelessness. In this context, let us relate the emergence of time to the processes of abstraction, memory, and quantum collapse. Based on the views of Whitehead, Bohm, and Hameroff, it discusses how time transforms from an infinite potential into concrete moments, and how this overlaps with human consciousness. Whitehead defines the passage of time as the transition from an infinite potential to a concrete reality. This transition is a process in which a choice is made from an infinite pool of information and possibilities, and the past is implicitly carried into the future. According to Whitehead, abstraction places an infinite present moment in the past by consolidating it into a smaller moment. This process allows an individual moment of experience to take shape. Each new moment contains all the information of the past, but as time progresses, this information is partially abstracted and lost. The process of abstraction parallels the subjective experience of the passage of time in human consciousness. This experience is the inclusion of the past into the present as an implicit feeling, and consciousness chooses among potentials at each new moment. In quantum mechanics, a system exists in a superposition of infinite potential states until it is observed. Observation or interaction causes the system to collapse into one state, which represents the transformation of potential states into a concrete reality. According to the quantum theory of consciousness, the processes of forming thoughts, making decisions, or performing an action are similar to quantum collapse. This process is interpreted as consciousness, creating a concrete experience by choosing one of infinite possibilities. Hameroff describes wave function collapse as the mechanism of time progression. The transition of quantum processes to the classical order ensures that time progresses. However, this process at the quantum level implies the fluidity of time between the past and the future, despite irreversibility. Hameroff's emphasis on irreversibility suggests that time can operate in two directions at the quantum level, but that this process at the classical level is limited to forward motion. Each wave function collapse gives birth to a new moment from timelessness. This process is similar to what Whitehead describes as concretion, the process of abstracting past information to create a concrete moment. Time progresses in a fractal structure with this cycle of repetition and collapse. Each moment carries the information of the previous moment and transmits some of this information to the future. This reflects the fractal nature of time. Each moment both repeats the whole and forms a small part of it. In Whitehead's view, each moment both contains timelessness and is a part of it. This shows that time is not just a linear progression, but a dynamic and layered structure. Whitehead states that time causes some of the information from the past to be lost. However, he argues that information can be perfectly preserved in timelessness. The future can affect the present through timelessness. This implies an aqueousness that goes beyond the one-way perception of time. This idea is compatible with the block universe theory, which points to the existence of a universal now. Whitehead's concept of God's concretion refers to perfect knowledge beyond time. As Hameroff suggests, each wave function collapse represents the rebirth of time. This shows that time does not just progress, but constantly recreates itself. Time is not just a linear flow, but a repetitive and deepening creation of an infinite present moment. Based on the ideas of Bohm, Whitehead, Penrose, and Hameroff, it is explained how time works as a constraint and also as an optimization tool, and how quantum timelessness and classical temporal processes interact. An entangled pair of particles share a timeless state in superposition. Measurement breaks this timelessness and puts the particles back into time, thus re-emerging the temporal and spatial distinction. The behavior of entangled particles, which appear to be transferring information faster than the speed of light, can be explained by the effect of timelessness. In this process, information can momentarily reach the future or a timeless dimension and be transported back to the moment of measurement. It is suggested that quantum systems collapse by receiving information from timelessness. This information can be perceived as an influence coming from the future, from the perspective of classical time. When the measurement takes place, this information becomes visible in the present moment. The transformation of quantum processes into classical temporal reality allows time to progress. In this transformation, consciousness plays an important role in the selection and transfer of information. The fact that time does not exist continuously at the quantum level indicates that time is an emergent property. At the sub-quantum level, time is replaced by a timeless superposition. Time is built on a timeless foundation. Every moment contains timelessness and is a part of it. This shows that time is not a linear progression, but a fractal structure. Finally, let's consider consciousness as a spectrum consisting of the stages of experience, awareness, and self-awareness. This spectrum explains how consciousness interacts with temporal dimensions and defines consciousness as a process of focusing that extends from environmental interactions to self-awareness. These three levels of consciousness are associated with the processes of deepening and expanding the perception of time. Consciousness is defined by the ability of an individual to project himself, herself, forward and backward in time. Remembering the past, planning the future, and establishing connections between temporal moments are the basic functions of consciousness. In this context, consciousness is seen not only as an individual awareness, but also as a relationality established with the environment. The parts con, together, and sire, to know or see, in the root of the word consciousness, express that the nature of consciousness requires duality and participation. This positions consciousness not as mere individual awareness, but as a state of knowing about an other. Consciousness is a process that promotes temporal deepening. This deepening occurs as moments are separated from each other to form more complex structures. Division functions as a fundamental mechanism that allows time to progress. Experience is the most basic form of consciousness and includes the capacity of all beings to respond to their environment. At this level, consciousness operates entirely within a timeless moment and is deterministic. The responses of inanimate objects are entirely determined by physical laws and, in a sense, remain in an eternal present moment. Awareness enables living beings to relate to their environment in a more complex way. At this level, consciousness includes memory and value judgments because organisms maintain certain preferences for survival. Awareness expands as past experiences are embedded in memory. Memory and choice divide a timeless moment, creating a longer temporal perspective. This process contributes to the expansion of temporal depth. Self-awareness, on the other hand, involves the individual's capacity not only to remember the past and experience the present moment, but also to imagine and make choices about the future. Self-awareness expands the perception of time through the capacity to evaluate future possibilities and make conscious choices. This allows individuals to access both smaller temporal divisions and to create a broader perspective across time. Self-awareness adds an internal representational layer that deepens the perception of time. This allows the individual to understand the effects of their environment and how they can relate to these effects. The spectrum of consciousness can be depicted as an interconnected loop, like a Mobius strip. Experience provides a timeless foundation and is the starting point for all forms of consciousness. Awareness deepens time through the addition of value judgments and memory in a timeless moment. Self-awareness allows time to be perceived from a broad perspective and connects to the other end of the spectrum of consciousness. This connection demonstrates that consciousness establishes a dynamic relationship between the temporal and timeless dimensions. Time and timelessness are fundamental elements that shape the nature and perception of consciousness. Consciousness is a process of focusing that deepens and expands the perception of time within a spectrum extending from experience to self-awareness. This process shows that time is not only a progression, but also an expression of timelessness. In short, the fractal model of time reshapes our understanding of temporality. Time is considered a dynamic structure intertwined with memory, consciousness, and the cosmic order. This model allows time to be interpreted as a process in which it both arises from a timeless origin and constantly begins anew within itself. This approach offers a deep understanding of the physical and philosophical foundations of time. Thank you for listening, and take care.